Hello and welcome to the video lecture on modulation or multiplication theorem or property of Fourier series. So let us first understand the statement of this property and then we will see the proof. So here this property states that if z of t is equal to x of t into y of t, that means the multiplication of the time domain signal xt and yt will result in the Fourier series representation as z of k is equal to x of k convolved with y of k. So multiplication in the time domain is equivalent to convolution in the frequency domain. That is what is the property of modulation. Now let us see the proof of the same. So according to the definition of Fourier series, can write z of k is equal to 1 upon t integration over the period t z of t into e raised to minus j k omega 0 t into dt. This is a standard definition. Now we will substitute the value of z of t. Here z of t is nothing but xt multiplied by yt. So 1 upon t integration over the period t x of t into y of t into e raised to minus j k omega 0 t into dt. But by synthesis equation, we have x of t is equal to summation k is equal to minus infinity to infinity x of k into e raised to j k omega 0 t. So now this value of x of t we will substitute in the above equation. Let's say equation number 1. So while substituting, what we are doing, I am going to change this index of summation from k to some another variable to avoid the same letter confusion. So now we'll have z of k is equal to, now see 1 by t will be as it is, then integration over the period t will be as it is. Now I will put this value of x of t. But what is x of t? This is summation k is equal to minus infinity x of k into e raised to j k omega 0 t. But now here instead of k I will replace it by a variable m. So I will write here m is equal to minus infinity to infinity x of m into e raised to j m omega 0 into t. So this is the value of x of t into y of t into e raised to minus j k omega 0 t into dt. Okay. Now we'll interchange the order of integration and we will rewrite this. So we'll get z of k is equal to, take this summation first. So m is equal to minus infinity to infinity x of m, and in bracket we'll write the remaining terms, that is 1 by t integration over the period t y of t, and now this term and this term. So what we are doing, we are taking omega 0 t common, j omega 0 t minus j omega 0 t we will take common. So we can write here e raised to minus j k minus m into omega 0 t into dt. Okay. So this quantity inside this bracket, if you see carefully and if you compare it with the equation of or definition, then you will understand that, see here it is zt and e raised to minus jk omega 0 t. So here there is a k, so coefficient will be replaced by z of k, but here if you can see, it is now instead of k it is k minus m. So now we can write it as, according to the definition, z of k is equal to summation m minus infinity to infinity x of m into y of k minus m. And if you see, this is nothing but a equation of a convolution, which is ultimately written as z of k is equal to x of k convolved with y of k. This is nothing but a required proof. So if you like my video, then please share the video with your friends and don't forget to subscribe to my channel. Thank you guys. Thank you so much.